Hi everyone, my name is Isabel and welcome to our Chemistry Magic Show. I'm the president of the Chemistry Club here at U of A. Joining me are our other officers, Christian, Kira, and Ashley. I'm a senior this year, majoring in chemistry in our chemistry and biochemistry department, so I'm about to graduate. I'm very excited. I hope you enjoy what we have, and thank you so much for coming.
Hi, my name is Ashley and welcome to the Chemistry Club Magic Show. I'm going to be walking you through the candle staircase experiment. As you can see, I've already lit all 6 candles. Now we're going to talk about dry ice. Dry ice is a special substance because it is a solid form. It is condensed carbon dioxide and it doesn't melt, it only sublimates, which means it only goes to a gas form. But if we stir it around, we'll get a subtle buildup of gas in the flask that you see here. And over time, we can use it to blow candles out.
Hello, my name is Christian, and next we're going to be doing magic ice. So in front of me, I have a big old beaker full of water, and I have an indicator. An indicator, all it is a way to measure pH visually. So when I add it to some water, it'll change the color of the water. Sweet. So pH is just a measure of acidity. So in this case with this indicator, the more yellow the indicator is, the more acidic it is. So think like lemons, very acidic. And the more blue or purple or farther away from yellow, more red, it'll be more basic, so think like some soap. So next up, we want to see what's in this mysterious bottle. We can't exactly tell what's in here. We got a label ripped off, so we want to see if it's an acid or a base. So we're just going to add it in and see what color it changes to. Sweet, so it turns purple. So we can then say that it's a base. So next up, I'm gonna add some dry ice that you saw earlier and see what happens. We're just gonna add all of it. All right, so it is rapidly sublimating. And what we have here is just water vapor. And if you look closely, you might see after a little bit of time that the color of our water where we added our base is going to start changing colors. You can start seeing it change now. Slowly, slowly. And that just means it's becoming more acidic, as shown by our universal indicator.
Hi guys, so my name is Isabel and today I'll be doing a trick that we call fire hands. So what I'm going to do is I am going to pump some really flammable gas through this bin of soapy water. And then what I'm going to do from that is scoop up some of the bubbles and I'm going to light myself on fire. So the reason I can do this, the reason I won't get hurt because of it, is due to the water. So the water actually has this property called a high specific heat capacity, which means it takes a long time for it to heat up. And so that's what's going to protect my hand. So if you can see, I'm going to dip my hand in water first, scoop up some of these gas-filled bubbles, and we'll light it up. And my hand's okay. Hi guys, so our next one is called Lycopodium. So I have in my hands just really, really flammable powder. And so what I'm gonna do is I'm gonna light it on fire. The trick about this one is that if it was just in my hand like this, I wouldn't be able to light it because there's not enough oxygen between each particle of this powder. And so what I'm gonna do to get more oxygen in it is I'm going to drop it in this pan. All right, in 3, 2, 1.
Hello, my name is Kira, and next we are going to do a little something called fire jugs. So I'm looking to make a really big fire. So first off, I have a little petri dish here, and I have a very flammable liquid called isopropyl alcohol. So I'm going to pour a little bit into my petri dish and hope I get a really nice fire. Ooh, that was a lot. And whoa, it's a little bit small. So I'm looking to upgrade it a bit, and one way we can do this is by getting a larger surface area, because the more space that a fire has to contaminate, I guess, the bigger it will be. So for that, I have a very big jug, and I'm going to fill it with our flammable liquid once again and run this experiment again. So you want to get a decent amount in. Give it a good swirl so we can get as much area as we possibly can. All right. Now we're going to light it in 3, 2, 1. So next up we have gummy bear torture chamber. Essentially what we're going to be doing here is we are going to be heating up some potassium chlorate and dropping a gummy bear in it, and the sugar within the gummy bear is going to react and make a really cool effect. So first off, I'm going to add our potassium chlorate to our test tube here that we have set up. So add a little more, just a smidge. And next up, we are going to heat it up with our torch. So we're going to heat it up until it's about to a boil. And next we shall drop in our gummy bear. And that's Gummy Bear Torture Chamber.
Hello. We're going to be taking a look at chemiluminescence. Chemi, just for chemical, and luminescence for light. So different reactions have different ways of expressing themselves, basically. Some reactions give off heat, some require heat to happen, some give off light, some give off radiation in some senses. But here we're going to take a look at chemiluminescence, so a reaction that produces light. So by themselves, they're kind of boring. They don't do anything, but when combined together, we'll see what happens. And so as these two substances come in contact with one another, first in the funnel and then throughout the column, they just react and give off a little bit of light. Welcome to Burning Rainbow. With me up here, I have a Bunsen burner that's currently going on all cylinders, and I have 3 different metal solutions that are in spray bottles. So what's special about these metals is that they change color when they combust. So first we have potassium chloride. It's a nice little pink. Next up, I believe we have copper. A nice green, and sodium, some orange. This is a reaction that happens in many different kinds of fireworks. So you can start to mix different colors to get different effects.
Hi, welcome back to Ashley Time. I'm going to be doing elephant's toothpaste. So, this is called hydrogen peroxide. I've carefully measured it out for you guys, so there shouldn't be any problems. I'm going to pour it into this flask now. Essentially, hydrogen peroxide is going to break down over time, but it's pretty slow and I'm impatient, so we're going to speed it up. I'm also going to add some soap just so we can get some bubbles to see the reaction easier. Now, I'm going to add the catalyst and we're going to see the elephant's toothpaste form. Now, if you look closely, you can see some steam coming off. That's because this is what's known as an exothermic reaction, which means heat is being released.
All right, so this one is called N2 Cloud. So what I have in my hands is a bucket of really, really hot water, and below me I have a bucket of liquid nitrogen. So when I mix the two together, because the liquid nitrogen is already boiling, it'll make a really big cloud. All right, ready?